Hey, welcome to 7.6. Similarity transformations. It says the objective is to identify similarity transformations and then verify similarity after a similarity transformation. A similarity transformation is a transformation made to a shape to make a new shape that is similar to the original. I know it's kind of a weird thing to say, but basically we take an original shape, we do something to it so that now the new figure is similar to the original. So it's the same shape but different size. And we've talked about transformations previously, but we talked about congruence transformations. And we'll just look at those really quickly. Congruence transformations changed like the location of the shape, but the size and the shape stayed the same, and those were translations. That moves a figure left to right, up and down, that kind of thing. Then we have reflection. So we might reflect or flip something over the X or Y axis. And then we had a rotation and where we would turn that. And in all cases, the figure stayed the same shape and size. For a similarity transformation, the shape will remain the same, but we might have a different size there. And in this case, that's called a dilation. A dilation is a transformation that's either going to shrink or enlarge a figure proportionally, producing similar figures. So shape's going to remain the same. We're just going to blow it up or shrink it. Dilations are performed with respect to a fixed point called the center of dilation, and that's just the starting point for any growth or shrink. So the starting point of growth or shrink. The scale factor of dilation, and this, you got to get this right, it's in a specific order. The scale factor of dilation is the ratio of the sides of an image to the corresponding sides of the pre-image. So we'll write that down. The scale factor of dilation is the image to the pre-image. And if you'll remember from our previous congruence transformations, we start with the pre-image and then we change that to the image, in this case, whether it's a larger figure or a smaller figure. But the new one goes on top. So this is the new and this is the original. And we have a little picture here. In this case, you can see that everything is coming from the origin. And so for this particular problem, that's the center of dilation. And then it says triangle JKL is a dilation of ABC, which means that ABC is the original or the pre-image. And JKL is the new figure or the image. So depending on what we get for our scale factor of dilation, we're going to either have an enlargement or what's called a reduction. And so we're going to let K be the scale factor. That variable is going to represent the scale factor. So if we end up with a scale factor that's greater than 1, then we have an enlargement. So this thing is getting bigger. And so you can see that if we went from triangle FGH to triangle RST, RST is bigger than FGH, so that's a an enlargement. And then a reduction is if that k is between 0 and 1. And the reason why we do between is because we don't want to have a negative value for our scale factor. Okay, so that's where we're going to shrink something. A couple of examples here of dilation. It says determine whether the dilation from A to B, so A is the pre-image, and B is going to be the image. Whether it's an enlargement or a reduction. So you can see in this case the change from A to B here. B is obviously larger than A, so that's going to be an enlargement. And then we want to come up with that scale factor then for the enlargement. So just kind of remind us, the scale factor, or I'm going to call it the SF, is corresponding sides of the image to the pre-image. The corresponding sides part's kind of important. So I'm going to take something that I can easily find the value of. I've got a side here on A that is 3 units long, and I've got a side here on B that is 4 units long. So the image has a length of 4, which corresponds to a length of 3 on the pre-image. So the scale factor is 3 to 4, and it's an enlargement. On figure B, we start out with A is the pre-image, and it's a large figure, and then to B, which is a smaller figure, so it's a reduction. Again, we're going to take the scale factor, and we're going to do a value from the image, which is B, and it has a length of 2 units. You can actually use any side as long as you use the corresponding side on the other figure. And then the corresponding side on A has a length of 6. So we would have a 2 over 6 there, which gives me a scale factor of 1 to 3. In example 2, it says find and use a scale factor. It says refer to the beginning of the lesson just about ratios and dilating a figure. By what percent should Adriana enlarge the ticket stub so that the dimensions of its image are 3 times that of her original? What will be the dimensions of the enlarged image? So, you know, kind of imagine you're putting it on a photocopier and you're going to enlarge this figure. And so I'm going to make a bigger one here. And I'm going to give these some variables to solve for. And it says that we want the dimensions of its image to be 3 times that of the original. So that means we're going to have a scale factor of 3 to 1, where the image in the numerator is 3 times that of the denominator. It asked us kind of a weird question. It said, what percent would we increase this by? That just wants us to change 3 over 1 to a percent, which would be 300 over 100, or 300%. Then we want to figure out what this x and y would be. So if my ratio would be 5 to x and 6.4 to y, and the scale factor, they should both equal 3 to 1, that gives me really 2 proportions that I could solve. I could solve for x and have 5 over x equals 3 over 1. Oops, sorry. Let's back that one up just a little bit. I'm going to flip my ratios because it's the image to the pre-image. The image is x, And the length of the side associated in the pre-image is 5, so it should be in this order. And then y over 6.4. Now I've got it set up correctly. So for the x, I have 6 over 5 equals 3 over 1. And when you cross multiply, I'm going to get x equals 5 times 3, or 15. And then I'm going to solve for the y and have y over 6.4 equals 3 to 1. And the same thing, y equals 6.4 times 3. And so y would equal 19.2 centimeters. All right, we're going to look at a graph. You very commonly see a dilation where we graph it, and it says graph the original figure and its dilated image. Then verify that the dilation is a similarity transformation. So for figure, the original figure ABC, we have -6, -3, 3, 3 for B, and 3, -3 for C. So this is my original. And you can see we would have a right triangle there. And then my image, my new figure is XYZ. X is at -4, -2. Y is at 2, 2. And Z is at 2, -2. And you can see that that's also a right triangle, and there should be some overlap there. You know, before we can verify that it's a transformation, first we want to look and see what kind of dilation this is. Is this an enlargement or a reduction? And so from the original to the image, it definitely got smaller, so this is a reduction. And then I want to verify that this is a similarity transformation. So I need to show that these figures are similar. And I see that I already have actually a pair of congruent angles because angle C is congruent to angle Z because they're right angles. So I have congruent angles. If I have proportional sides surrounding those, then I can use side angle side to confirm that it's a transformation. So within this figure, I want to then compare AC to XZ. If that is proportional to BC over YZ. If those are proportional, then this is a similarity transformation, and that's how we would confirm it using either maybe angle-angle similarity, side-side-side similarity, or side-angle-side similarity. We just need some values to go with this. So AC, we just count the units. Let's see, we have, so this looks like it's 9 for AC, and for XZ is 6. YZ is 4. And BC is 6. So we'll put those values in. AC 9 over 6. We want to know, is that equal to 6 over 4? And those reduce to 3/2 here and 3/2 on this side. So the answer is yes. And this transformation is a similarity transformation. And we know that triangle ABC is similar to triangle XYZ by side angle side similarity. All right, here's your assignment. Enjoy, and I'll see you the next time.